I am Dr. Ramya Swetha, Assistant Professor from Civil Engineering Department. Today I would like to explain regarding impact of jets. So this is the one of the important important topic which we have to understand in our hydraulic machineries. So the term jets can refer to several different things. So coming to these impact of jets, these are the some of the web references we are going to understand the topic very it's very easy to understand. These are some of the web resources. Now coming to the impact of jets. So it is the jet. The jet, it is a stream of liquid coming out of nozzle with a high velocity under constant pressure. So it is a jet means whenever the complete like this, the jet of water or liquid, whatever it may be, the combination, the set of all the drops or individual particles all come together with some nozzle from for example from tire, whenever we are using tap, from the tap, and once you release the tap, so the water it will comes. So the set of the set of that stream of liquid coming out of from the nozzle with a velocity, with a high velocity and constant pressure. It's the velocity it comes under, it's high, and the pressure it should be the constant pressure. So the pressure whenever we required, how much we required, so these are the setup, the complete, that is known as jet. So this jet, how it impacts the jet, how it impacts under various situations, based on the various conditions, how we understand this jet. So coming to this, the jet is a stream of liquid coming out from nozzle with a high velocity under constant pressure. Now, impact of jet means the force exerted by the jet on the plate, which may be stationary or moving. So whatever the jet is there, that is nothing but the stream of liquid coming out from nozzle with a high velocity and constant pressure. The complete jet impacts means, it means the force, whenever the force exerted by the jet on a plate, which may be whether the plate may be stationary or moving, whether the plate it may can any kind of situation, like whether it may be vertical or angle, which makes any certain a number of it makes some angle, either it is maybe 60, 30, 45, it depends upon the requirement, and it depends upon the fulfillment of that particular project. So like that we have to understand the impact of the jet under various conditions, whether it is the stationary condition or in the moving condition. The plate may be flat or curved. It is also one of the parameter which we have to understand whether. So in this, impact of jet means the force exerted by the jet on the plate, which may be stationary or moving. The plate may be flat or curved. This force is obtained from, so these complete whenever the impact of the jets, which is a force exerted by the jet of the plate, so whether it is maybe stationary or moving. So in this, in that particular, the plate, coming to the plate also, it may be flat or curved. It depends upon the requirement or fulfillment of that particular project. So this force is obtained, whenever we now talking about this force exerted, this force is obtained from Newton's second law. So this force is obtained from Newton's second law of motion, or it based on the impulse momentum principle. So based on the impulse momentum principle, we are understanding the complete impact of the jets under various conditions. So this is the impact of the jets. Now based on the what we said, so the complete, whenever the force exerted under various plate conditions, whether they are moving and physically the structure is in moving condition or stationary, and the plate it should be maybe flat or curved. So whatever maybe it is, coming to the force, which is we are understanding from the impulsive momentum equation. So based on the impulsive moment theorem, it states the change in the momentum of an object equals the impulse applied to it. So this is the statement which we are going to understand the impulsive momentum theorem. So this is states the change in the momentum, whenever the change in the momentum of an object equals the impulse applied to it. So in this, force is equal to d with respect to the mv. So here we may write like this: m dv dt plus dm dt. So for constant mass, this is nothing but the mass. This m represents the mass. Coming to this, the constant dm is equal to 0. The constant dm is equal to 0. Change in momentum may occurs due to change in the magnitude of velocity or in its direction or due to both. It depends. So coming to this, so with respect to the force is nothing but the derivative with respect to time, mass into velocity, that may convert it into mass into derivative velocity with respect to time plus derivative of velocity, and it is derivative of mass with respect to time. We may write like this. So for this constant mass, so the dm is equal to constants. It means finally m, the derivative of mass is constant. So whenever the change in momentum may occurs due to a change in the magnitude of velocity or in its direction or due to both. So now we are going to understand force. F is equal to dv by dt with multiplication of m. So this portion is remains because of the change in momentum. So it may occur due to the change in magnitude of velocity. So it may occur. So it depends. Again, it depends upon the particular condition. So based on that condition, it may occur due to a change in magnitude of velocity or in its direction or due to both. So because of the change in the magnitude of velocity, so for constant mass dm is equal to 0. Now force is equal to mass into dv by dt. So like this we are understanding this impulsive momentum theorem. So based on this impulsive momentum theorem, we are going to calculate the understand the force which is obtained. So it is obtained law of Newton's second law of motion or impulsive momentum principle. So this is the based on these principle we may understand the force. So coming to this, these are the following cases of the impact of the jet, that is force exerted by the jet on a plate will be considered. So n different number of cases we may observe. Basically, force exerted by the jet on stationary plate, force exerted by the jet on a moving plate. These two are the parameters which we have to understand clearly. So the whatever the things which happened in these are again sub-categorized. So force exerted by the jet on a stationary plate and force exerted by jet on a moving plate. So these two are the force exerted by with respect to plate. So with respect to plate, we are understanding these two. So coming to this, in this plate is vertically to first we are considering the stationary plate. Coming to the stationary plate. So whenever the plate, it may vertical to the jet like this. This is the jet of water, just for understanding. So jet of water or liquid, whatever it, this is like this. In this means whenever the stationary plate is like this, like straight. This is the plate. This is the stationary plate. It is straight like this, straight. So this is the jet of water. So whenever the jet of water is in this direction, the plate is like this. This is the plate is vertical to the jet. Some other case it may jet of water may like this. This is the plate. Means the plate is vertical to the jet of water. It based on the from the base from the plate. From basis on the plate, we are understanding the how the force exerted by the jet on that stationary plate. So the plate is not a moving condition. It is a plate which is not comes under in moving condition like this. So whenever the jet of water is moving in this way, and this is the stationary, and it means it is fixed. This is fixed one. This plate is fixed. It means stationary. There is no movement in that plate. So the plate is vertical to the jet of the water like this. This is the one of the condition we may understand. And the next one is whenever the plate is inclined to the jet of water. So the jet of water is like this, and the plate is like this, inclined. It makes some angle with the jet of water. It makes some angle. So which makes some angle, makes angle. So this is the inclined. So the jet of water is inclined. So this is another case. And the next one is the plate is curved. The plate is curved plate like this, maybe like this. So many different types of curved are available like this. So this is the curved plate like this also. In this also again the plate, the jet of water is in straight or in terms of tangential. It depends upon the conditions which we have in that particular. So these are the various the way of expression of jet in terms of plate. So plate is vertical to the jet, plate is inclined to the jet, plate is curved. So force exerted by the jet on a stationary plate. So these are the three conditions. Comes to the force exerted by jet on a moving plate. It means the plate is going to moving. It is also some velocity. The plate is also having certain velocity. It is moving. The plate is moving. So like this or like this, whatever it. So the plate is moving. Moving plate. We are considering the moving plate. So force exerted by the jet on a moving plate. Plate is to the vertical to the jet, plate is to inclined to the jet, and plate is curved, similar to the stationary plate. So this is the basic categories which we consider. In that, these are the subcategories. Those subcategories are, it may change. Otherwise, this is another way is there for expressing the so these are the this is the another way is there for the force exerted by the jet on plate. We'll consider that is force exerted by the jet. Plate is vertical. Plate is vertical. This is one. In these subcategories are whenever on stationary plate, on stationary plate, and on a moving plate. We may write like this. And the second case, some of the cases, the following cases like this are like this, we may express force exerted by the jet. Plate is inclined for stationary plate condition. On stationary plate, B is moving plate. The next one is force exerted by the jet exerted by the jet plate is curved. The third condition, force exerted by the jet on a curved plate, whether the plate is stationary or moving. So like this also we may express the cases. So impact of the jet in terms of force exerted by the jet on stationary plate, again those subcategories, and force exerted by the jet on a moving plate, those subcategories. And similarly, plate is vertical, those subcategories, plate is inclined, subcategories, plate is curved, subcategories. Like this also we may express the various cases in these two different ways. So we may follow according to your understanding and according to the requirement and according to your consideration. We may follow any one of these categories. These are the cases we may follow. So coming to the first one, force exerted by the jet on the vertical flat plate. So first we have to understand what are the parameters are involved in this particular situation and in this particular condition when the plate is stationary. So in this is the stationary plate. So this is the stationary plate which is fixed. This is the stationary plate which is fixed, and this is the jet of the water, jet of the liquid which is coming from the nozzle. This is the nozzle, and the jet of water is coming like this. This is the jet of water or jet of stream liquid. This is the jet of water, the complete. In between, this is the axis of the jet, the overall, the collective, this stream. This is nothing but the jet of water. And from this pipe, this is the pipe, this is the nozzle, this is the stationary plate. This is the stationary plate. In this, we have to understand what are the parameters involved in this. Coming to this, V is the velocity of the jet in the direction of the x, D is the diameter of the jet, A is equal to area of the cross section of the jet. So this area of the cross section of the jet, it is depends upon the direction of the diameter of the jet. So diameter of the jet is equal to, it comes under circular, pi by 4 d square. Pi by 4 d square. This is the area of the cross section of the jet. So it is the area of the cross section of the jet. So once we understand the figure, once the jet of water which is touches the, so these are the parameters and these are the things which we understand in this force exerted by the jet on the vertical flat plate. So in this, first we have to understand the things right now. So area of cross section of the jet, so that is equal to pi d square by 4. Now we have to understand consider a jet of water strikes a stationary vertical flat plate which is shown in figure. So in next class, we will understand what is the force exerted by the jet of the water and complete all the parameters in this. We will understand in next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.